Solving a logarithmic equation. For solving logarithmic equation, which are the equation that the x or the variable is inside a log function, we are going to use a one-to-one property for most of the cases. Depends on the problem. But something that's important, I will explain the different method that we can use for solving logarithmic equation, but something that is important, after solving each equation, we need to check for extraneous solutions because the domain of logarithmic function has a restriction, and we know that when we have a function like f of x equal log x base 2, when we have this function, we know that whatever is inside the log should be always positive, not zero, not negative. That means when you are finding the domain, you have to set that greater than 0. And when you find a solution for any logarithmic equation, you also need to check the solution to make sure that that number is making all logs, keep all logs or all arguments positive. How do we solve logarithmic equation? To solve logarithmic equation, we mostly use one-to-one property. But first, we have to make sure that the logs on each side are isolated. Let's look at the first example. In this example, part A, you see that we have a log on the left side and we have a log on the right side. And both of the logs are isolated. No numbers adding, subtracting, multiplying. When we have the log function isolated, we can use the one-to-one property, which tells me if two logs are equal to each other, that means that those terms also must be equal to each other. That means I can remove the logs, especially when the bases are the same, and I just set arguments equal to each other and solve this equation, which is easy because it's a linear equation, and I just need to move the x to one side and numbers to the other side. So we get x, which is equal to 8. But as I said, after finding a solution for every equation, we need to just go back and replace the x by that number and make sure that inside the log is always positive. If you replace the x by 8, you will get 2 times 8 minus 7, which is 16 minus 7, it's 9, so it's positive, it's okay. If you replace the 8 here, so you get 8 plus 1, which is 9, and it's also positive, okay. So we checked and everything is fine, and we can accept 8 as a solution. Okay. So to solve logarithmic equation, make sure that each side of the equation has only one log. That is very important. And then use one-to-one property and remove the logs and set the arguments equal to each other, and then solve using only the argument. Okay, let's look at another example. Okay, part B. That's a logarithmic equation because x is inside the log, okay? And then I see logs on the left side and I also see logs on the right side. So I have logs on both sides. That means I have to use one-to-one property. But to use one-to-one property, I need to make sure that there is only one single log on each side. There is only one single log on the right, but on the left, I have two logs that are subtracting. And I need to use the properties of the log to make it in one single log. And based on the properties of the log, whenever the two logs are subtracting, that means I can divide those together. So I have ln of x minus 2 over x. I will just bring down the other side. I'm not touching that because there is only one single log. And every time you have one log on the left, one log on the right, that means it's not canceling. It means that if the two logs are the same, the two arguments must be the same. So I have to set them equal to each other. and try to solve this equation. To solve this equation, since I see an x on the denominator of a fraction, so first thing that I need to do is just getting rid of the denominator. How we can cancel the x on the denominator? Just multiplying both sides by x. So multiply both sides by x. So we get x and x cancel each other. So we have x minus 2 on the left and 54 times x, which is 54x. Now I just have a linear equation and I only need to move x to one side, numbers to the other side. This time I want to move x to the other side, to the right side. So we get negative 2, which is equal to 53x. And then x must be equal to negative 2 over 53. Okay, that is the answer. But whenever we find a number, we need to check that can it be a solution or not. If I replace that number in this log, we get ln of negative 2 over 53. But we said this number inside the log cannot be negative. If it makes it negative, that means it cannot be a solution. So what is the solution for this equation? Okay, there is no solution because I only find one solution and that cannot be accepted because it's making inside the log negative. So for this equation, we don't have any solution. For some equations, for some logarithmic equation, we may need to use definition of log, means converting the log to exponential form. When do we do that? When we have only one log in one side of the equation and the other side doesn't have any log. Okay, let's look at this example. If you see only one log in one side, but the other side is just a number, no log on the other side. So in this case, first we need to make sure that the log term is isolated, is by itself in one side, and then try to convert it to exponential form. So to have log by itself, the first thing that I need to do is just isolating the log. So I have to move 15 to the other side. So we have the ln of x minus 3, which is equal to 6. Okay, now I have one single log on the left side and a number on the other side, which means since there is no log on the right side, I need to convert it to exponential form. For converting to exponential form, we always start from the base. And you know that natural log, or ln, it's a log with base e. And if you convert it to exponential form, like in zigzag direction, so we have e to the 6th power, that must be equal to x minus 3. Now it's easy to find the x. And don't forget, your goal is finding the x. E to the 6th power is just a number. You can find it with the calculator, but you can also keep it as e to the 6th power. But to isolate the x, we just need to add 3 to the both sides, and x must be equal to e to the 6th power plus 3. And using calculator, you may get a decimal number, but we can leave it here as well. Do we have to check the solution? For sure, we have to check the solution. So the only log that I have is this one. Okay, I have the ln of x minus 3, and I will replace the x by e to the 6 plus 3. 3 and 3 cancel each other, and we just have ln of e to the 6. Is e to the 6 a positive number? Yes, because e is 2.7, and even if you raise it to the 6th power, you still have a positive number. So let's look at next example. Again, when we look at this log equation, we see two logs on the left side, no log on the right side, which means I should use the definition of log and convert it to exponential form, because there is no log on the right side. But we also know that on the left side, we just have to have one single log. Do we have one single log? No. We have two logs that are adding together. And based on the properties of the log, when two logs are adding together, that means I have to multiply those two terms together. Now I have one single log on the left, number on the right, so I have to convert it to exponential form by starting from the base and going in this direction. So we say 2 to the 5th power, which is equal to x times x plus 4. And to solve this equation, first we have to drop the parenthesis and find the exponent, see what do we get. 2 to the 5th power is 32. Multiply 2 by itself 5 times. Distribute the x by the parenthesis gives me x squared plus 4x. Okay, now I have a quadratic equation because the power of x is 2. So for quadratic equation, I know that there are two methods, factoring or using quadratic formula. But for any of those methods, I need to have all the equation in one side, and one side must be 0. But right now, there is no 0 on one side. So I have to make it. So subtract 32 and move it to the other side. And we get x squared plus 4x minus 32, which is equal to 0. Now I can start solving this equation. I'm going to use AC method, a times c, which is negative 32, b, which is 4. I'm looking for two numbers that if I multiply them gives me negative 32, and if I add or subtract them gives me 4. And those numbers are positive 8 and negative 4. So I can open two parentheses, x plus 8 and x minus 4, and then use zero product property and set each of the parentheses equal to 0. I have two solutions here, but which one can be accepted as a solution? So you have to replace them into the equation. If you replace 4, 4 is a positive number. 4 is positive, 4 plus 4 is positive, so it's okay. But if you replace negative 8, it gives you log of negative 8. It makes the argument negative, so negative 8 cannot be a solution. So the only solution for this equation is positive 4. Next example. We have a word problem. It says Vanessa deposited $5,600 in an account that pays 8% annual interest and compounded quarterly. How long will it take until Vanessa's balance is 10,000? Okay, it's talking about compounding. That means that's a compounding formula. And since it's compounded the quarterly, I have to use the compounding interest formula, which is this formula. But I know that for this formula, I need to have A, P, R, N, and T, or have most of them and find the missing. Let's see what's given to us. When it says Vanessa deposited $5,600, that means the principal or the initial money is $5,600. Account pays 8% annual interest, which means the rate or R is 8%, but I always change the percent to decimal form, which is 0.08. It says compounded quarterly, that means we have 4 quarters in a year, which is n is equal to 4. When it says how long will it take, that means find the time, find the t. So the t is missing. Until Vanessa's balance is 10,000. Vanessa's balance is A, so A is 10,000. Okay, so just replace them into the formula and try to find T. As you see, after replacing the numbers, T, which is the missing term, it's on the exponent of something. That means I have an exponential equation to solve. When I have exponential equation to solve, based on what we learned so far, we know that we have to have the exponential term isolated first and then check if the bases are the same or we can make them the same. Otherwise, use log. So to simplify this one, first find inside the parenthesis. What is 8% divided by 4 plus 1? So 0.08 divided by 4 plus 1 gives me 1.02. Let's bring down the rest. But to solve any exponential equation, the exponential term, which is this part, must be by itself in one side, must be isolated. I have to get rid of 5,600. And since that is multiplying, I need to divide by that. Divide both sides by 5,600. And 10,000 divided by 5,600, it's 1.7. Let me just keep it with 3 decimal digits. Okay. And then now based on what we learned for solving exponential equation, we need to look at the bases. The bases are not the same on the right and left, and we are not able to make them the same, so we have to use log. So I will put the log on both sides, the log of this number and the log of this number. Okay. Log, let me to move the power. So I will have the log of 1.786, which is equal to 4t times the log of 1.02. My goal is isolating the t. T is on the right side, and everything that's next to the t must be removed from that side. Right now, I see that there is a 4 and there is a log on the right side, and they are all multiplying by t, which means to cancel them, I need to divide both sides by them. So divide both sides by 4 and by log. Divide both sides by 4 and the log. Now I have t by itself, and I just need to find the other side. What is the log of 1.786 divided by 4 times log of 1.02? But don't forget that when you put this one in calculator, to make sure that the calculator is following the correct order operation, put this whole in a parenthesis. And we put log of 1.786 divide by, open a parenthesis, 4 times log of 1.02, and close that big parenthesis. So the answer for t is 7.32. That means how long will it take until Vanessa's balance is 10,000? About 7 years, 7.32 years, which is more than 7 years.